let's briefly look at this diagram and see how we can resolve the forces and probably calculate for the reaction forces and draw the bending moment and the shear force diagram. So if you can see, we have to find arrow A and arrow B. So I have to use this principle that says that the sum of these downward forces is equal to the sum of the upward force, which is this relationship. So I have this. So I also have to use this other principle that says that the algebraic sum of moment about any point is equal to 0, making reference to point A. So it means that arrow B will act in this form. Arrow B times 10. I'm using anti-clockwise as positive and clockwise as negative. So arrow B will multiply the distance to the reference point, which is 10. Then 15 will multiply, 15 is in this form, clockwise, I'm using negative. Multiply the distance from this point to this point, which is 8. 30 is the same thing, and all it will amount to what? 0. So I have this multiply this, 10 arrow B minus this times this is this multiply this is this, and so on. So finally I take all this to this other side. I have this. So 10 arrow B is 310 is equals to 310. For us to get arrow B, you have to divide by 10. So arrow B is giving us 31. We have arrow B as 31. So recall that arrow A plus arrow B is 65. It means arrow A will become 65 minus arrow B, which will give us what? 34. So I have this reaction forces here. Arrow B and arrow A have been gotten, 34 and 31. So let's proceed. Since I've gotten the reaction forces, we can proceed to get the shear force value. So the shear force value becomes this. Inertial force will minus as we progress. So at point A, the shear force there is equivalent to what? The value of arrow A, which is 34 kilonewton. So what I mean is that at this point, the shear force here is equivalent to this value. So the shear force at point C will become what? 34 minus 20, that is 34 minus the next force, which is what? 20, we have 14. The shear force at point D becomes 34 minus 20. This is what I mean. This 34 minus 20 minus 30, the shear force at point D. So have that. So also at point B, which is the last one, becomes 34 minus 20. You minus the forces as you progress. Minus 20 minus 30 minus 50 will give us this, and so on. So you can see we have the shear force values. We have 34, 14, minus 16, minus 31 kilonewton, and so on. So the next thing for us to compute now is the bending moment values. The bending moment at point A is 0 because there is no perpendicular distance at that point. So we have 0 at that point. Remember that the bending moment value at point B is also what? 0 kilonewton per meter. So we have gotten the bending moment at this point, and at this point. They are all 0. Alright, so let's proceed. Now the bending moment value at point C becomes this reaction force, which is this multiplied by the distance 2. So it will give us what? 34 times 2 will give us what? 78. So let's proceed. The bending moment at point D. At point D, what is the bending moment value? The bending moment at this point becomes this multiplied by the distance 5 minus, since this force is acting down, we'll use minus 20 multiplied by 3. So let's proceed. So we are having 34 multiplied by 5 minus 20 multiplied by what? 3. We have 110. They are positive 110 kilonewton meter. So the bending moment at point E becomes 34 multiplied by the distance to the reference point, which is what? 8, minus 20 multiplied by 6 minus 30 multiplied by what? 3. That's exactly what we're going to have. So 34 multiplied by 8 minus 20 multiplied by 6, 30 multiplied by 3. So finally we'll have this. So the next thing for us to do is to draw the bending moment and the shear force diagram. So but before you can be able to draw this diagram, I have to draw the free body diagram. So I'll say free body diagram. We'll draw this, indicate all the forces and the distance where they are acting from. So as you can see, the shear force value at this point takes the value of arrow A. It will be constant until it meets the next force. At this point, what is the point here? Is point C. The shear force value at point C is what? 14. So we are coming downward a little from 34 to 14. This 14 will be constant until it will meet the next force, D. The shear force at D is what? Is minus 16. So to come down to the negative side, this 16 will be constant until it meets the next force, which is point E. So what is the shear force value at point E? The shear force value at point E is what? Is minus 31. So it has to come down. This 31 will be constant until it closes at this point. So how the shear force diagram drawn. So the bending moment, I'm using down to be positive and upward to be negative. So the bending moment now at this point is 0. At this point is also what? 0. So the highest bending moment is at what point? It's at point D, which is 110, the highest positive value, followed by what? The next one is at point what? Point C, which is 78 here, followed by the next point, which is what? Point E, which at this point 62. You know that this is higher than this, so this is the highest bending moment diagram. So I connect them.